in this class, I would start you off with something like this and say, find me the integral. And if you were to try this out, if you were to try to find this integral, you might start by guessing and checking. Anybody want to guess as to a common first guess would be if you didn't know how to work with integration by parts? What would be a guess as to the integral? Improper, yeah. Not improper. Yeah, you might try something like a half of x squared e to the x. And then I would ask you to check that answer. And how would you check that answer? You would differentiate that. And what would happen if we differentiate that? What happens? What do we have to apply? The product rule. So it splits into two things. Yeah. Then you think to yourself, well, I only want one thing. So I'm going to add a subtraction in there and try to cut something out. And it's kind of fun. You got to go in circles for a little while. What's nice about it is possible on some of these to guess and check yourself through the wilderness and actually get to an answer that works. It's also particularly nice because what's a really nice aspect to that function that we're integrating right there? Exactly. We love this, right? We love this. Makes us happy. It really makes us happy. Made us really happy in Lagrange error bounds, right? Because it's just rising, so you'd pick the thing to the farthest to the right, you'd use that, and you'd be home free. It wouldn't blow up on you. What are we actually going to need to do? Well, you've probably seen this before, and depending on your book, and you used the same book last year, did you use U and V? Yeah, it depends on your book, U and V. As a side note to this, mathematicians are terrible about picking pairs of variables. I don't know why they pick U and V. Why do I think U and V is a terrible pair to use? They look the same, and they kind of sound the same. It's almost as bad as M and N. Why? I don't know. We like P and Q. At least P and Q can be verbally different, but they look the same. Anyway, what's going on here? Both U and V are what in this case? U and V are both what? Functions in terms of what?
Variables.
In terms of x, yes. They are functions in terms of x. So what did we just apply right here if we do this? We just applied the product rule. You've seen this before. You apply the product rule, you rearrange things, and then what do we do? Or what am I going to lead you to? You guys have done this before, so you're teaching me here. We don't have to implicitly, yeah, we're just going to anti-differentiate. So we've differentiated, we're going to rearrange a little bit, and then we're going to integrate. Anybody want to guess as to what we're going to pull to the other side? What do we like to pull around here? Do you remember what the rearrangement is? Anybody? You're helping me out here. I don't know what's going on. James?
U prime V equals UV minus.
Yeah, see, this is where it gets kind of annoying because you could pull U prime V to the other side. Or what could you pull to the other side? Theoretically, does it matter which one you pull over there? No, it doesn't really.
But it depends which function you and
Exactly. It really depends because your choices matter a great deal. Is it possible to make choices for U and V that don't help you at all and make things a lot worse?
I think that's most of the time.
Absolutely. Yeah. If you're not doing that all the time, then you're not trying hard enough on these. These are specifically useful in cases where it's not obvious what the choices are. So, you wander through the woods a little bit. You say d dx of uv minus maybe u prime v is equal to u v prime. And then they just like keeping things on the, let's keep it on this side, equals, I don't know, d dx of uv minus u prime v. Maybe something like that. Something like that. Like, okay, all we've done so far is we've differentiated with the product rule and rearranged. We haven't done anything earth-shattering here. And honestly, when you see this for the first time, it doesn't seem like it's that helpful until you've applied it and understand where it actually is helpful. At this point, what do we get to do to both sides? We get to integrate with respect to dx. So if we integrate with respect to dx, u v prime dx is equal to, what happens to this magical thing? It becomes what? It becomes UV due to what theorem? Remember what it's called?
Second fundamental.
Yeah, FTC, fundamental theorem of calculus. Different books label them different ways, 1 and 2, 2 and 1. You can say the fundamental theorem of calculus. And what do you end up with here? Minus the integral of u prime v dx. In general, one thing you can do to make my life easier and your life easier is keep u in front of v. Write things in alphabetical order. It's a small thing you can do to help me, because I can guarantee the existence of integration by parts problems where there are multiple substitutions that you can make that will work. Some of you will make one substitution, some of you will make another substitution, and I have to sit there and try to make sure it all works. Just try to keep them in alphabetical order. Okay, so when you're making your choices, you remember some of the rules about maybe tips for making your choices, how to apply this? Remember some of the rules? Because you can't just go out and choose anything, right? Yeah, when you're looking at this right here, you need to be able to immediately write out the right-hand side of this equation. So if you have v prime, what do you automatically have to be able to find? V. So you better be able to just know the integral of v prime. Similarly, so v prime better get better. Similarly, what happens to u? It goes to u prime. So when you take the derivative of u, it better get simpler. In this direction, we're looking for things that make your life simple. So written out with nice format, it's kind of like that right there. It's really nice. So a nice summary of what you're dealing with here. It helps if u prime is simpler than u. It's not always going to be the case, but it helps. The other thing is the word simple. Is that kind of subjective? Yeah. Absolutely. It's like when a math book uses the word clearly. What are my thoughts on the word clearly in math books? I hate that word with a passion. Because either you've seen it and you don't need your book reminding you that you saw it, or you don't see it and your book just insulted you. Okay? I hate that word. So simple, it's okay. It's okay, but you get the general idea. So how about this? You try this on your own right now. Try this on your own by parts right now on your own. Intelligence. There's different ways to set things up. The easiest way to mess these up is to not write everything down. So you're looking at, what's your choice for u? What did you choose for u, Jesse? Did you choose u? I think ln x is a good choice for you. Okay, if that's correct, what's u prime going to be?
1 over x. 1 over x.
Dx, right? Yeah. So if that's correct, what's v going to be then? 1. I think you have to be, I like, can put v, we have to figure this out here. I mean, when I meander through the woods here, you know that one of them is going to be u. If that one's u, what's the other one going to need to be? V prime. Well, dx is the thing that's left, yes. So v prime, let's say that's dx. So what's v going to be? 1. V is 1. Right? Or is it just x? Is it just x or is it just 1? What is that? Is it x or 1?
X.
It's x. Because what's actually in front of this dx right here? There's a 1 in front of it, right? So when you integrate this, you end up with x. Just be careful. Okay, so now when we write this out, you should, just by practice, if this is not totally automatic for you, get into the habit of actually writing out integral uv prime is equal to uv minus what? Integral of? At least write that out. You're missing some things on there, but at least write it down, because the easiest way to get this wrong has nothing to do with calculus. It has everything to do with just misordering things. It gets very sad, right? So what do we end up with? U times v. Oh, that's going to be x ln x minus the integral of what? Was it u something? What is it? Oh, u prime v. 1 over x times v. Oh, look at, is that cool when that happens? The key thing is, do I have limits of integration on this?
Yes.
Yes, I have 2 and 3. But no, not on this one. Yes, you're absolutely right. On this I don't, but in the original question, do I? So you have to make sure when you put them in correctly. Oh, there they are. You have to make sure you put them in correctly. It happens all the time that kids do not put them in correctly. So when you get something like this, what do you automatically identify as being something that makes you happy? Yay! It's because I wrote it wrong. It's 2 to 3. Thank you, Jesse. Immediately call those things out. Please continue that. So what do you end up with? You get 3 ln 3 minus what? 2 ln 2? Something like that, I think. Minus, well, that comes out to be 1, right? What's the integral of 1? It's going to be x from what to what? 2 to 3. Am I doing this right? Did I make a mistake?
No.
I think I'm okay. Minus 3. 3. And why am I doing that? I don't know. It's very strange. How's that? Is that okay? I know. James really likes to compact these things, so he gets ln of 27 minus ln of 4 minus 1. And then he likes to write it as ln of 27 over 4 minus 1. Sure. Sure, that's totally fine. Totally fine. 2x dx. Okay, if that's the case, if we pick u is equal to x squared, what's v prime going to be? Sine 4x dx. So if that's v prime, what's v going to be? Minus 4? You sure? Minus 1 over 4 cosine of 4x. Derivative of cosine is negative sine. Oh, it cancels with the negative. Chain rule kicks out the 4. 4 cancels with the 1/4. Are we happy? Okay. So now if we, again, are there limits of integration on this one? No. What's this kind of integral called?
Indefinite.
Indefinite. I'm kind of cool with that. I don't really want to evaluate these things. So we have a product here. So we end up with, okay, u times v. Okay. So x squared times sine of 4x minus, we don't really care. If that's ugly, we don't care. Because do we have to integrate that thing, u times v? No. We're subtracting u prime v. What's that going to be?
Oh wait, I think you have to put negative.
Hold on. One person at a time. One person at a time. Go ahead.
Instead of sine 4x,
I put v. Did I plug the wrong thing? Oh, I did the wrong one. Thank you. So it does matter if I write down the completely wrong one. That is correct. Thank you. So it's negative 1/4 cosine 4x. Thank you. Minus u prime v. So what's u prime? Oh, that's 2x dx times what?
Negative 1/4.
Negative 1/4 cosine something x, 4x, right? Can we pull anything out to the front of there?
Negative.
We got a negative, let's just do this. X squared cosine of 4x minus what, negative 1/2?
Yeah.
And what do we end up with? X cosine 4x dx. This is the moment where we've been waiting for, right here. Well, we're like, oh, great. It doesn't seem like it helped us that much, but what can we do again? You could do by parts again, because you get to here, and it looks very similar to what we had, but what's the key difference? We've reduced the power of x by 1. So if we do this again, are you going to be presented with integrations that you have to use parts more than once? Absolutely. Absolutely. So don't get all dismayed and think you're in the wrong direction because you got hit a wall. You got something that's simpler. Yes, there's this thing out front, but that's just along for the ride. You ignore that now until the end. So if we want to do this, we kind of have a hint. What is u going to be? Oh, x. Not d. What's u prime going to be, Brendan? Just going to be? Yeah, dx. Remember the dx. So if that's true, what is v prime going to be? Cosine of 4x dx. So what's v going to be? 1/4 sine x. So now keep in mind we're just dealing with that. Ah, man, I'm not doing well today, huh? See, you should have brought me the coffee. Man. Next time. So u times v, we get x over 4 sine of 4x. Hey, I copied it right this time. 4x. So now what do we have? Let's just eject to the, we're going to bring this down. Negative 1/4 x squared cosine 4x. Don't forget about it. It gets lonely. Plus 1/4. Did I get something wrong? Which one? This one right here? Oh, there's a sign wrong? Times the whole thing. So we got x over 4 sine of 4x minus 1/4 the integral of sine 4x dx. Now, why are we so happy right now? We can actually just do that. We don't need to use parts anymore. We do not have to use parts anymore. And now it's just a matter of keeping track of all these signs, right? As I've proven, is it really easy to mess up the signs? Yes. Yeah, it is. What was it, 1/8 of x sine of 4x, right? And now we have to be really careful here. We're going to have minus 1/8 of, what's our integral of sine 4x dx? 1/4 negative cosine of, I don't need more parentheses than absolutely necessary, like this. I think that's the right thing. So if you wrote this out, you end up with, you know, the only thing that strikes me as a little bit depressing about a problem like this is I love the fact that we have a concrete answer. Do we have a concrete answer? It's plus, right? Yeah. We do have a concrete answer. The thing is, we started with something that looks so pretty. look, all we changed was we got rid of that little integral sign, right? And look what happened. Okay? I think the moral of the story here is keep track, write stuff down, and don't lose negative signs. By far, I mean, I think you guys have a pretty good handle with parts as long as you practice it. Parts as long as you practice it. Okay, so you really only have one choice for u. What's u going to be?
Cosine.
Nice. Okay, so let's say u is cosine of theta. So what's u prime going to be?
Negative.
Negative sine theta d theta, right? So if u is cosine theta, what's v prime going to be? It has to be what?
Cosine theta.
Cosine theta d theta. Okay, so therefore, what's v equal to?
Sine theta.
Is it sine theta integral? Yeah, I think it's sine theta, right? Nice. So we say that this now is equal to u times v, and what do you end up with? Cosine theta times
Sine theta.
sine theta minus u prime, so that's negative sine theta d theta, times what?
Negative sine squared.
Well, it's just times sine theta, right? So at this point, you probably are a little sad. Why are you a little sad?
You have square root of sine.
Plus of what? Sine squared what?
Theta d theta.
D theta. You're kind of sad, right? So at this point, you're like, man, I got to try something else, right?
Sine
Wait. So what is sine squared equal to?
1 minus cosine squared.
Okay, so I'm all sad, and now I'm going to write it as 1 minus what?
1 minus cosine squared.
Cosine squared theta. Are you okay with that? Now, I'm saying algebraically is what we've done so far correct?
Yes.
Well, I don't really like integrals with parentheses, so I'm just going to break it apart a little bit. Cosine theta, sine theta, plus the integral of just d theta minus the integral of cosine squared theta d theta, right?
There's no same.
Okay, are we okay with where we are right now?
Yes.
What was the original thing we were trying to integrate? The integral of cosine squared d theta. You see this? What can we add to both sides?
Integral of cosine squared.
Oh, so you end up with 2 times the integral of cosine squared d theta is equal to cosine theta sine theta plus what? Theta. Oh, we have 2 of them, so what do we divide both sides by? So you end up with the integral of cosine theta d theta is equal to 1/2 of cosine theta sine theta plus theta. That's called a cool trick. It's a really cool trick. Because here's the problem. If you try to get clever with trig substitutions, you end up doing this. And it just expands, and it gets all nasty, and it's just the same thing over and over again. You need to walk away with 2 lessons from this example. The first one is you need to recognize when you're about to fall down an infinite loop of recursion. You need to recognize early, because if you do this for 5 minutes, I'd like you to not waste those 5 minutes and go, I know I'm going to get stuck. The second thing is see this trick once, and it'll happen again. It'll definitely happen again. I can guarantee on a test I'm going to give you one where you're going to need to recognize the double of what you were originally, or triple, or some multiple, some scalar multiple. Move it over, divide, you're done. It's a great trick. I love this trick. It gets more fun too because I theoretically, don't do this, but I could ask you this. That's not 4 theta. That's supposed to be sine to the 4th.
Oh.
Do you end up having to do a similar type of thing?
Yeah.
You end up, it folds in on itself, and then you can do it again, and then all of a sudden you can add everything together and divide. The point is, this right here is just sine squared, squared, right? So you can attack it from the inside and work out. Just be really careful. Be really, really, really careful. We have a few minutes left, and I want you to work on these questions right here. We skipped over it. So how about you try this question right here? Try that question right there. So what did I say you should probably choose for u? Because u prime is going to be, what is u prime going to be? Over x dx. So if that's correct, what does v prime have to be? X to the 6th. So what does v, so what does v have to be?
7.
Yeah, 1 over 7x to the 7th. If you do this out, it cancels really, really, really nicely. Well, kind of nicely. And you end up with, anybody have a final answer? 1/7 x to the 7th, ln x.
149.
Yep. Plus c.
To the 7, that's plus C.
To the 7, right? Oh, to the 7, thank you. Yep, plus c.